Arduinos are so cool. You can get them nice and cheap. They're easy to code. Plenty of people have shared their projects on the internet, so it's really easy to access pre-made code and just adjust it to suit your own needs. Because they're cheap, you can pretty quickly accumulate various different parts and sensors and all that sort of stuff. So really cool piece of equipment to have. I've got a couple of displays down here. First of all, I've got this LED matrix. It's 8x8 with a little Max 219 controller. This is a pretty standard Arduino add-on board. I'll be using a potentiometer as my main sensor. The system should be able to work with a whole range of analog sensors though, so that's the plan. Lastly, I've got this little 1.3-inch OLED display, something you can get for $3 or $4 off AliExpress or somewhere like that. So I'm going to try and get this thing working as well. Really what I'm aiming to do here is set up on this piece of Vero board a demonstration model for 3 different kind of LED metering systems: the OLED, the LED matrix, and if I've got room left over, I'll be setting up a LED meter kind of arrangement. The idea of this little project is to demonstrate 3 different ways that you can use an Arduino with some various display technology that you can easily purchase or make yourself. It's a project that is aiming at the high school student age. I'll be sharing this in one of my classes at school. Actually, my students in that class are already doing this project, and they're doing quite well on their own without my direction, but I thought it might be nice for them to have a circuit that they can look at to help them to come up with their own ideas of how they might make a similar system. I'll share the link to the code in the description of the video. So what I'm going to do is I'm going to snip off some of these header pins, and I'll just desolder these bent ones and solder back in some straight ones. That'll be how I attach back down to this board. So I'm going to position this here, and I'll probably position this around here so I can place some connecting wires and additional hardware and all that sort of thing. So I'll push those pins back through that way, and at the same time I'll place this item as well. And I'm just going to solder those connections. And these are some nice bits I've got left over from some kit to make my job quite a bit easier. I'm just going to find the right ones. So what I think I might do, make one of these a positive and one of these a negative, and then I'll tap into the VCC for both displays and then join these 2 pins together here. So hopefully I can find pieces that connect perfectly in this little bag of goodies here. That should give me a constant voltage and ground for both displays, which I can also tap in later for my LEDs. My next step is going to be to get some pin-to-pin cables and create the wires that come out to join onto the Arduino board, and I'll just solder them into their correct places. So I've now got 5 wires here to join back to the board, but I'm going to have more because I'm going to be setting up 3 LEDs so that the meter can basically read empty, half and full, and that'll just demonstrate a nice simple meter. So what I'm going to do is I'm going to put 3 LEDs in the system, 2 green and a red. So red will be kind of the bottom of the scale. I'm going to use a single current limiting resistor, 220 ohms, and I'll join that to the ground part of the circuit. To do that, I'm going to actually place my resistor, I'm going to place my LEDs up here on some of these pins, and I'll place my resistor between this bus bar here and ground. So ground, of course, being the outer pin. I'm just going to judge the distance by eye and bend those pins neatly so that they are a good distance apart. I'll pop that resistor here. Now I'm just going to evenly space my LEDs with the ground leg toward the resistor, and I'll try and space them a nice distance apart. This is going to leave me room over here to place a potentiometer. That's going to be my test sensor. And it's time to snip some tails. Now the legs of my potentiometer don't quite fit through the holes. I don't want to force them, so what I'm going to do is I'm just going to open up those holes a little bit with a drill. The legs of the potentiometer are 1 millimeter wide. So I'll get my 1 millimeter drill out of this horrible little thing if I can. I'm just going to use a pin vise, and I want to drill, where do I want to put this thing? Around about here. So I'll just sneak this drill bit through. Now my potentiometer should fit nicely into the board. It's a little bit tight still. Is the other potentiometer better? Yes. Now once again, the potentiometer has a VCC and a ground. I'm going to use some jumpers to connect those two. I feel like orange is the right length. Let's see. It's the right length, but it's in the wrong spot. Now I'll place a red one to join the VCC for the potentiometer. Next, I want to connect up all of my pins to their various locations on the Arduino. In total, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll also need a ground and a VCC, so that should be 11 pins in total. What have I got on this little group of wires here? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I'm going to try and keep my wires fairly close together if I can, and hopefully I'll be able to route them back under something like that. But this is where my placement of components might not be ideal for that sort of setup, but we'll just see how it goes. So I think I'll try and use red and brown as my 5-volt and ground lines, black and white for the SDL and SCK or whatever they are on the OLED. I did say the ground was the outside, so that would make brown wire to the outside, red to the inside. I still need to get these two to sit in place, SDK and SD orange as the A0 pin. I'm going to need to put the legs for the LEDs up the top, because if I wanted to put them down the bottom, I would have been better off doing that with the legs the other way around. Well, that should leave me 3 pins for the OLED display to connect right about here. I think that might be the way I do it. So I'll just go and solder all of those pins in place. Since I chose to place the analog pin on this side of the circuit to make it easier to solder, I'll need to put in a jumper like I did just down there. So I'm going to sneak a jumper in there. So later on, what I can do is I can hot glue all of these in place. That'll give me some kind of mechanical protection on these wires. But that's a problem for future, Anthony. Right now, what I want to do is test this circuit out. So I'm going to now start connecting up the other ends of the wires to the Arduino. Now, SDA is white, so the white pin can go here, and SCK on the OLED, it says SCK. On the Arduino, it says SCL. Hopefully they'll work just the same. Then I've got a ground and a plus 5-volt pin, and I chose to use red for 5 volts and brown for ground. So I'll plug those in there respectively. I had an orange pin for A0. Now my LEDs are yellow, green and blue. I'll make blue pin 2, then The middle LED can be pin 3 and the end one can be pin 4. And that should leave me with 3 more wires which I can connect to, I think it was pin 7, 11 and 12, or 7, 10 and 11. But to get that, I'm going to need to actually have a look in the code, and you can see that here. Data in 11, CLK 13 and load is 7. It's time now to test out the whole setup. I've only got a short little USB cable here, so hopefully I can fit all this in and still get it on screen. Okay, so currently have my code loaded for the LED display. Oh, and that's not doing anything. A quick reset and that seems to bring it back to life. I don't know what it is with these LED screens that they jam up like that. I'll upload my LED matrix code now. Do a quick reset of the Arduino. I'll do a quick blink circuit for the LEDs and see if I can make them work. Okay, so at least that's working. So the OLED is working nicely for a while and then it stops. Okay, now I think one of the problems I've got here with this LED matrix is that this pin here, when I desoldered it, I did do a pretty rough job of desoldering. I think I've actually damaged the soldered pad for that pin. So what I'm going to do is scrape back some of the circuit protection and just resolder that, spreading the solder over back along that track a little bit. And I think, hopefully, that's the problem I'm having. That will be the problem I'm having with my OLED, my LED matrix solved. It looks like I'm getting some feedback back through the circuit here, because if I disconnect the positive pin there, the OLED display here still is powered. And if I disconnect the ground, there's still a little bit of juice there too. Or can reconnect ground and I get a little flicker on the OLED display. Ooh, I can see I've crossed over some solder join there. Maybe I should have put my glasses on before commencing this project. So I've actually managed to solder these two pins together, which is the, I think, DN and CS pins of the LED matrix. I should be able to turn the potentiometer and have all 3 meters respond accordingly. So that should be a pretty simple task to merge these 3 sets of code. I'll place all the 3 separate Arduino sketches along with a 4th one which shows all of the measurement display systems working simultaneously. Okay, now this is for the ultimate test. I've merged all the 3 codes together and wanting to have them work simultaneously. Okay, so I've got my value here. I've got nothing on the LED matrix. As I turn the LED matrix up, this one is working, this one is working. My display, however, is not working. So let me just reset and update that with the value at high. Okay, it is working now. I'm finding with these OLEDs that sometimes they just drop out and stop working. I'm not quite sure. In any case, this is the demo unit, and you can see displays 3 different options for students to work on as a project. A really good next step would be setting up these wires with a bit of mechanical protection. I can use a hot glue gun to do that. Hot glue is so messy. All right, so there we are. I've put together a demo unit with 3 different projects on it, which can basically demonstrate to people in this case my students, 3 different ways that they can create a meter to measure an analog input. This project could be used on a range of sensors. I'll be showing how I can use some additional sensors with this project later on. Anyway, until next time, bye for now.